Okay, thank you. Welcome you again at the last day, third session of this 5-day FDP. So, what we are going to have a discussion today, that kind of algorithm we didn't cover. Actually, if I try to recall, as many of the experts have already mentioned, if you try to categorize AI or any ML algorithm, broadly there may have another category. Broadly we can say we have a unsupervised method, we have an unsupervised method, and we may have a supervised method. So all the methods that you consider as a part of ML area may be subcategorized as unsupervised method or supervised method. In the supervised method, we have seen again sub branches like regression kind of method or classification. So we have covered one algorithm in the detail that is called linear regression. And we can mark as a linear regression is a kind of supervised learning. And we have seen with all the mathematical background, theoretical background with the implementation. So I thought we should also cover one of the algorithms that fall under the unsupervised learning. So unsupervised learning, there are one of the category is you can say clustering, clustering. Under the clustering, many methods are there. Many methods are there. Today we are going to discuss about the k-mean. Today we are going to discuss about the k-mean. So as we have seen also in the first lecture, unsupervised learning also we say it is sometimes we can call it descriptive method, descriptive method. And all the supervised learning algorithm we call the predictive method. So just names are so important when you go for a study or when you are going for entering a new area. So sometimes we can also categorize the algorithm in the way of that they work. So descriptive algorithms, you can say, where all the unsupervised learning comes under that. That is a bigger name. Descriptive analytics is a bigger name. And another is the predictive analytics. Another is the predictive analytics, where all the supervised learning comes. There may have another branch that is called prescriptive analytics. Prescriptive analytics. I'm not going to that much of discussion. So why I'm asking it is that, so when you study any kind of algorithm from the scratch, you should understand where you are standing for. You are learning something descriptive method, unsupervised method, or you are learning predictive or supervised method. So that you should know. So start with the clustering. Yeah. So as I discussed, the clustering is unsupervised descriptive data analytics. So we don't need to anything try to memorize it. So somebody will call the clustering, yeah, clustering is a part of unsupervised learning and unsupervised learning is a part of descriptive data analytics. So one line easily you can recall. It will help you to make a picture. So the clustering, unsupervised learning or descriptive data analytics. A lot of definitions are there. A lot of definitions are there. Just for a sec, I'm going to just read a very simple definition that will try to connect the concept we are going to study. So the clustering is a task of dividing the population or data point into a number of groups. So if somebody will say what is the clustering in one line, so I will say the clustering is something where a data set is given to you, and you have to subdivide the data, or you have to divide the data into multiple groups, into multiple groups. So you can say the group 1, group 2, dot dot dot, group n. Sometime you can call it cluster 1, cluster 2, or cluster 3. So what they're talking about, clustering is a process of subdividing, subcategorizing a population or data set into the subgroup. That subgroup technically we call the cluster, such that such that the data point of the same cluster or same group are similar. Similar. If where the data points belong to the any group, the same group, if the data points are the member of the same group, they should be similar. They should be similar like that. One condition. Another condition is that if you try to compare the data point of a different group, this should be dissimilar. Dissimilar. So what are the guiding parameter that you can consider when you should divide or you try to divide the data into the subgroup? You can do it, but you always keep in the mind the data that are member or part of the same group should be similar. And if any of the data of that are belongs to the different group, they should be dissimilar. You may ask a question, what is a similar or what is the meaning of similarity? What is the meaning of dissimilarity? So there is not a human being involved. Then you can say these two persons are look similar. Then the two persons are not similar. So I will also discuss what is the meaning of similarity and what is the meaning of dissimilarity, how to quantify it, how to mathematically quantify it. So I will also discuss. So the objective of today is that I will take an algorithm that is called k-means algorithm that will divide the data into the multiple groups, and each group we have to calculate the similarity and dissimilarity, and we try to uh, optimize my clustering process so that the data that are part of the same group will become more similar. So black and box, the way I have explained about the what we are going to study. So before dive into the detail, let's have the example. Let's have an example. So again, let me write the definitions so that you can connect yourself. The clustering is the task of dividing the population or the data point into the number of group such that the data points in the same group more similar than the data point those are in the another group. That is okay. We got it. So cluster means whatever the data set was given to you, divided the each group. Now the each group we known as a cluster. So the cluster is a group of objects that belong to the same category. We already understood that, and share the similar property. We already understood that. This is one of the requirement. Now each cluster that it created, that like C1, C2, C3, you can give its name, whatever the name you want. It's up to you. So how to decide the name of that cluster? Sometimes it is called label. Sometimes it is called label. How to decide it, I will also help you to understand it. For that, we need to take example. So suppose the data set is given to you. You can consider the customer data, maybe Big Bazaar data, maybe Reliance Trends data, maybe any kind of data you can consider. And any shop that used to deal with a variety of item. Suppose a big data was given to you. You applied a clustering process of your choice, and output of or result of that clustering process is that it has created the two group. For simplicity, you assume that the number of the subgroup you have chosen is two. So the complete data set was given to you. You have subdivided the data, and the data are grouped into the two different cluster. Now you need to analyze it further. The clustering is not going to help you. Try to understand. Once the cluster was created, a cluster created by the algorithm, you have to analyze the cluster. So you always require domain knowledge. So suppose managers are there, they analyze the group individually, and they concluded that there is a red color cluster where the group of persons who frequently purchase electronics items. Because it is a property of the clustering is that if the person belongs to the same group, should similar property, should share the similar property. Now you should try to connect yourself when somebody talk about a similar property. What is the meaning of that? The nature of customer or nature of data that belong to the same cluster should share the similar pattern, similar trends, like that. Meaning of similarity means it is a group. Red color is a group of cluster. So those are the customers are grouped over there, similar buying pattern, you can say. So most of the customer are here, you assume that suppose are whenever they visit our shop, they purchase the electronics item. Similarly, another category of customer you can think about that they are grocery item lover, because whenever they visit the shop or the center, they used to purchase the daily item, daily usable item. So you can give the name, you can label it. The label is that electronics item lover. You can give the label of that customers, and the label you can give for the another category, grocery item lover. So here, one question over there. Once the clustering process applied, the new group or cluster get created, and based on the property they share, you can assign a new label to them. So that is called how to give the labeling to the cluster. So these labels are going to help you a lot. The question is how. You can consider a scenario where the new electronics item the company have launched, and you want to advertise it. So and you have a limited staff, or you have a limited you want to make it very cheap advertisement. You don't want to call everybody, you don't want to send the message to everybody, because the customer may get annoyed for that one in that way. So what you will do, you'll try to find out the cluster you have, you can use it for your purpose. Yeah, because if you try to send a message, you try to contact them, the persons of the red color cluster, then there chance to improve business, because those are those person who used to purchase the electronics item. So it is called target advertising. You have to target the person. It is not fruitful to send or call or contact all the customer you have. It is not a good way of advertising. So the new concept is the target advertising. So you have to target it. But who is going to help you? These are the target. The clustering is there. The clustering will group the customer based on the behavior, and based on the property you can give the new name, new label it, and based on the label you can target it. So like that you can use the clustering for in very purpose in the market. Okay, so going ahead, it may happen the left color or left is the 2D graph of the data point, and the right hand side the graph is after the clustering. Here the three clusters were created. So physically we are not going to divide the data. We are not going to disturb the distribution of the data. The data distribution means the relative distance between the point, among the point, we are not going to touch it at all. We just give the label of them. We just give the label of them. So many students are confused here. If you ask the question, clustering is going to divide the data, uh, or we just cut the data and paste somewhere else, and we called it the cluster one. It is not happening at all. It is not happening at all. So that confusion I just experienced with many of the students. For that purpose, I am just going to explain this concept. Suppose the data set was given to you. This is the data set. Assume that this is the data set was given to you. A lot of rows are there, and suppose that is the age, or that is a salary, and that is a height, and that is a weight, like that. Okay, so data were given to you. You applied it into the clustering process. Suppose you apply the clustering. You apply the clustering. What is going to happen? It will divide the data into the, suppose, three cluster you have created. Three cluster you have created, C1, C. So what is going to happen really? It will include a new column. Clustering process will include a new column. In that new column, it is called a label or whatever you want. It is going to say the row one is belong to the group one or cluster one, cluster one. Next data in the cluster two, next is cluster three, then cluster one. Like that is going to happen. We are not going to edit, we are not going to touch, we are not going to disturb the existing data at all. We just create a new label, and the label just we are just mentioning the knowledge where the particular serial number or row belong to which cluster. That is output of clustering. You can assume that. Okay. I hope it is clear to everybody. The chat box is open before me, so you can write a question parallelly if you want to have a discussion or any confusion. You can directly write in the chat box. I am just it is front of me. So now going for the more detailed discussion, what is going to happen in the clustering? So there is a two objective functions. There may be a multiple objective function, but in the clustering there is a two objective functions. Any machine learning algorithm comes with the objective function. If you try to recall a linear regression, in the linear regression, what was objective function? Anybody can guess it? Anybody can just have a hint about what is the objective function in the linear regression? Just a chat, right? What is the objective function you have? You think it is an objective function in the linear regression. Objective, what is the objective of the training method? Once you train the linear regression, what is the objective? What is the objective? In the chat box, you can write predict. No, that is not objective. Yeah, minimizing the error. The objective function is that SSE. That is objective function. Whether you want to maximize it or whether you want to minimize it. So whether you want to minimize it, whether you want to maximize it, that is objective function for what? SSE. So in that way, if you try to recall any of the algorithm in machine learning, they comes with the objective functions. They may have a single objective function, they may have a multiple objective function. Similarly, the clustering algorithm, not k-means. I'm not studying, or I'm not just covering the k-means. K-means algorithm I will start. The fundamental concept of the clustering I'm discussing, it applied to any clustering algorithm you may study in future. So it comes with the two objective function. First objective function is that point within each cluster are similar to each other. I know that. It's called intra-cluster distance are minimized. That is called homogeneity. So if somebody will call homogeneity, I want more homogeneous. Homogeneous means more similar. More similar means they are very close to each other. So this I have to minimize it. So in that way, you can just understand the terminology. Homogeneity means homogeneous. Homogeneous means more similar. More similar means more close to each other. So that is called intra-cluster distance. The distance between the within the cluster, it is called intra-cluster distance that I need to minimize it. That is called one object function. Got it? Opposite is that points, a data point or observation from the different cluster are dissimilar. Inter-cluster distance are maximized. That is called heterogeneity. Heterogeneity means how the way they are different. So if two data items are belong to the different cluster, this should be heterogeneous. That is one of the property of the cluster. So when I going to consider the two data points of the different cluster, that is called inter-cluster. So inter-cluster distance, I have to maximize it. These two terms are two objective. Everybody have got it. The chat box, you can just write your response. Homogeneity and heterogeneity. Yeah, some point may be on that boundary, but must be a part of particular cluster. Yeah, thank you. So going ahead, thank you. So that like in that way you can understand. So suppose that, thank you, all the data set were given to you. You have grouped them into the three cluster, and when I discuss about the data points of the same cluster, the distance there, this would be so close. They should be very dense, you can say. So that distance should be minimum. My objective is that when I will try to consider the data point from different clusters, they should be as far as possible. They should be as dissimilar as possible. So you can understand it with the example. Okay, going ahead. So application of the clustering, I am not interested to discuss about at all. So just I will read it for you because there is a misconception. A lot of applications comes with the classification of the or the supervised learning. Myth. The fact is that there are many applications that are unsupervised way you can solve it, that are more than the supervised methods, supervised learning problems. Just come with me and I will list it over here. The clustering you can use for the market research, the pattern recognition. A lot of applications are there. Data analysis, image processing. Clustering can help also marketers to discover the distinct group in their customer data, as I have given the example at the beginning. And they can characterize their customer group based on the purchasing pattern, like an Amazon.com. When you purchase some item, when you log in it start giving you some suggestions. The customer who have purchased this item also purchase with that one. Like that, they start giving the suggestions. It is a clustering. In the field of biology, the plant and the animal taxonomy, you can just create it by using the clustering, which plant or which animal comes under the which category, which species they belongs to, that you can find it out with the help of clustering. The scientific reason, scientific way to do it. And all the land used in the earth observations like that, Google Map or any kind of geo related applications you look for comes under the clustering. The flood analysis, forest, how the forest is spread around the city, around the state. You are going to analyze by using the clustering. The Google.com, one of the biggest example. It's based on the clustering. I know there may have a combination of the clustering and classification. Then completely they develop the particular system. But the fundamental concept is the clustering. The Google.com. The moment you will type something, you try to create a cluster, and the item of those cluster they are going to show you in the list in the website name of the website. When you type the Google something, suppose that is a google.com. Okay, so suppose I have written triple IT, so it is going to create a cluster, and the items and the results, it is visible to you. It is a member of that cluster. In that way you can think about that. Outlier detection applications, detecting anomaly behavior, and many ways, many applications are there. So you can consider almost everywhere clustering is there. Okay, so that one more. Let me the link. I have just attendance link. Just I have shared, and it is enabled now. You can give the attendance if you want. So the attendance link just I have set in the web box, WebEx chat box, and the same link that I have used in all the days. So you don't worry about the new link or the revised link. The same link I'm using for the attendance. I just used to enable it, disable it. So the link is enabled. If you have all the link in the previous day, you can reuse it. Okay, thank you. So the clustering method, where you can divide the clustering methods in multiple category, in multiple subcategory. Suppose some methods comes under the partitioning based clustering. Sometimes you can call hierarchical clustering. Sometimes you may call the density based method, and many more are there, like a rule based clustering and grid based clustering, and many methods are there. And these are the category. It better to say, not method. So partitioning based category, a lot of algorithm comes under there. The k-mean is one of them. So don't think that partitioning based method means k-mean. A lot of algorithms comes under that category. Similarly, hierarchical method, a lot of algorithm comes under that category. Density based method, a lot of methods are there. DB scan, one of them, so famous. Everybody should know about the DB scan. DB scan, one of them. So today we are going to study about the k-means only under the partitioning method. We are not going to cover all the algorithm. We don't have that much of time. In the partitioning method, what happened in the partitioning method? Suppose we have given a data set of n observations. So we can partition the given data set. We can construct the k cluster, or you can divide the given data set into the k partition. Each partition will represent the cluster where the k is equal to less than n. Yes, because you have n number of points, you cannot create a cluster that is greater than n. So it means that it will classify the data in the K group. The n data set is given to that, and number of observation is given to that. You have to class. Don't confuse with the classify. Classify means just dividing it into the K subgroup, such that each group contain at least one object. What is the meaning of that? Means it is not possible a cluster, empty cluster. There is no concept of an empty cluster. Not say this is the cluster having a zero number of or nil observations. This kind of cluster is not possible. So at least every cluster at least will contain at least one object. One thing is belong to the one group. So there are two kind of clustering. I'm not going to discuss over here: hard clustering and the soft clustering. Just for a simplicity, I just want to make it clear. If you are interested, so just let me recall it. Clustering. It is sometimes you can consider a one way of seeing the problem with hard clustering. One time you can say it is a soft clustering. So in that hard clustering, overlapping is not possible. Overlapping is not possible. Overlapping is not possible. Here, there is only one difference. Overlapping is possible. Means it sometimes may happen. This point may be a member of cluster X1. This point may be a member of cluster X2. So some sharing of data point is possible in the soft clustering. But in hard clustering, the overlapping is not possible. That is a one difference with that one. So I think you got it. That point is very simple, very intuitive. Oh, as we discussed today, our objective is to discuss the k-means clustering algorithms that comes under the partitioning based method. Now we are going to start the discussion on the k-means algorithm. So the k-means algorithm, I try to recall, is perhaps the most common, most studied algorithm by the academician, by the industrialist, by the student, by the researchers. So if you try to Google it, a lot of version of the clustering, you will get it. A lot of versions are there: fuzzy clustering, centroid based clustering, or median clustering, mode clustering. Many kind of clusterings are there. So today we are going to discuss the clustering that is a very simple first version of the clustering that we can understand as a author first time they have introduced that method. The very basic and simple method we are going to see today. So what is the key point? Starting with the key point that we should keep in the mind, or that is a feature of the k-means clustering, you can say. So the first bullet point is that the k-means algorithm assign of each n example to one of the k cluster. It's damn clear. So whatever the data points are given to you, it is not possible. This data points are unassigned. So you cannot say data point is not a part of any cluster. The first thing you should keep in mind. This question comes in many exams. So whatever the data points you have given, data point may be outlier, may not be outlier. I don't worry about that. Every data point must be a part of cluster. Not there is no chance that particular observations are unassigned. It is not there. Second, where yeah, what that is a, you can say one of the problem with the k-means clustering. Sometimes the researchers talk about what is the limitation with the k-means clustering. Sometimes the researchers talk about like a k means what, why it is called the k-means clustering. We try to understand. K means the number of cluster you want to create. So here the problem is that what really that is a very big problem. The solution is there also. The data is given to you that you need to divide it. So somebody will say k is equal to 2, why? K is equal to 3, why? K is equal to 4, why? And what is the ideal value of the k? What is the ideal value of the k? What I'm asking the problem in the k-means clustering, a user have to decide. User have to decide the value of k. K is a parameter. Suppose k-mean is a function. K-mean is a function you have to call algorithm. Then you have to pass a data set. Then you have to pass the value of k. This may you can understand very easily. Data set means the data, the input you want to hear to subdivide it, and how many division you want. The question is who is going to divide that cluster, and how to get the ideal number. Problem with the clustering. Okay, but the solution is there also, because one, you have to apply the given number whatever you are thinking, maybe any number case could you can apply. The later there is some method. One of the method is elbow method. If the time permit, then I will discuss, otherwise I will not discuss. The elbow method is a method that will help you to find out the value of k, ideal value of the k, or you can say the suitable value of the k. So just I'm just flashing the name terminology. So if we failed to cover in these classes, the later you can just recall it. So the LB is one of the method that help us to find the suitable value of the k. So this thing is written over here, where the suitable k is a number that user has been determined ahead of the time by using the LB method, but must be given in the advance at the beginning. So that thing I explained. I hope it is clear to everybody. Now, goal, these two objective functions we are talking about. So the goal is to minimize the difference within each cluster, means homogeneity they are talking about, and maximize the difference between the cluster, the heterogeneity they're talking about. So these already I have explained the detail. It is already covered. It is already covered. Okay, these are the key points that you can understand for any clustering process. Not major. First, try to understand it is a recursive process. The clustering is a recursive process, not clustering. It's better to say the k-means, because we are studying the k-means. K-means is the recursive process. Means some set of steps we have to execute multiple time. That is a recursive process. So the whole k-means algorithm we can divide into the two phases. That is called updation and assignment. So that the thing we have to understand, what is the meaning of updation and what is the meaning of assignment. And these are those phases that we have to execute multiple time. Okay, so let's have a discussion about that. First, it is each example to an initial set of k cluster. Procedure means algorithm I'm talking about. First, it assigns example to an each of the k cluster. What it is saying? It is saying yeah, it is saying suppose that was the big data, or a large data set was given to you, and suppose you are looking for the three cluster. You want to yourself divide the data and the k is equal to 3 you have set. So suppose this is the item. Suppose you have to assign randomly to any of the cluster. This item suppose is a member of that cluster. This is a member of another cluster. So whatever the data points are given to you, you just assign randomly to any of the cluster. To any of the cluster. So that is what? That is called assignment. Assignment process or phase. Okay. Then updation come. Then updation. What is the meaning of updation? Okay, that I will discuss. Let me do one by one. First, it assign the example to the initial set of k cluster. It is over. Then it update the assignment by adjusting the cluster boundary. What is the meaning of adjusting the cluster boundary? Let me discuss in detail. Very important part. Very important part. Suppose, let me take an example. Suppose this is the data set. Randomly, uh, this is the cluster 1. Suppose now k is equal to 2. Simplicity I can consider. And this is the cluster 1. So there is a two cluster 1 and cluster 2. You randomly have assigned. The assignment process is over. Assign. First time. We need to iterate it. Now we have to call updation. The updation, what is going to happen? We have to calculate the centroid of the cluster. Centroid of the cluster. That is called, you can say the centroid C1, centroid C2. So we have to calculate the distance of all the data point to the centroid, all the data point to the centroid, all the data point to the centroid. Again, one misconception. I don't think we have to calculate the distance from the data point that is a part of that cluster to the centroid. No, all the data points, that is whole data set. Whatever data set is given to you, all the points, from all the points you have to calculate the distance. To repeat this process for the C2 also, means we have to calculate the distance of all the point from the C2 also, from the C2 also, from the C2 also, from the C2 also. This thing is okay in the chat box. It is clear to everybody. Whatever the total observations you have to calculate the distance. You have to measure the distance to both the centroid or both k number of centroid. Thank you. Now suppose you consider this data set. This data set. Suppose just this the process you have to repeat to everybody. Suppose this is the data points having a distance from the C1, having a distance from the C1 2 kilometer. Very simplicity is consider, and the distance from the C3 having 1 kilometer. So what is the interpretation is that? Sorry, C2. Okay, this data point is a part of the cluster C1 having a distance from centroid is 2 kilometer. This is the observation is not a member of the cluster 2 and having a distance from the centroid 2 is 1 kilometer, means this data point is more closer to the cluster 2, not in the cluster 1. So it was the wrong assignment. It was the wrong assignment. It was the wrong assignment because randomly you have done. So what you have to do? Now you have to make the boundary. You have to adjust the boundary. Now it become a part of that cluster. Why I have to adjust the boundary? Because physically you cannot touch the data point. You cannot disturb the distribution of the data. Data distribution is intact. But the cluster boundary you can change it. You can update it. So what you have made in the updation process, you realize that by comparing the distance from a particular observation to all the center, and you have to reassign it to the cluster having which centroid is very closer. That thing we have to apply to each and every data point. Each and every data point you have to do it. Each and every data point, and you have to readjust its membership. You have to readjust its membership. So it is called updation. Okay. Then the next process, what happened? A lot of data points have changed their assignment. A lot of data points change their assignments or their cluster. So once a new data item will include over here, or either some data points will go out, move out from the here, centroid will change automatically. Centroid will change. Then you have to again calculate the centroid. Again, you have to measure distance data points, and with the new centroid, some data points may change their membership. So this is a iterative process. This is a very iterative process. So that point you have understood. Assignment, updation over. Then again, can the question is that can centroid change their value during making this decision? Yes, always, always. That's why iterative process. What is that? Very simple example you can consider. There were three data points, 1, 2, 3, and centroid was this one. Here only two data points. Now this point we have removed from here, it become a member of that one. The centroid will also will change, also get changed. And because one item we have removed over here, what is the centroid? You can say the formula is what? Suppose two-dimensional data is there, x1 plus x2 plus x3 divided by 3, and y1 plus y2 plus y3 divided by 3. It is a formula if we have a three data points in the case of that one. Now what we have done during the updation, we have removed from here. So the formula we have to again readjust the formula. It will get the new value. new centroid. It will get the new centroid. And similarly, we have included that point over here. It will also get the new centroid. Again, you have to calculate the distance from all the points among all the points. So it is an iterative process. It is an iterative process. And now the question is when should stop it? I will discuss. So up to this data point, everybody got it. The concept. They have learned the concept. Chat box, you can write your response. Okay. Thank you. Okay. So now next important concept of the same algorithm we are going to discuss, very important. You can say the last concept we are discussing. Next is that we got it, then we update the assignment by adjusting the cluster boundary. We got it. Now the process of updating an assignment occurs several times until changes no longer improve the cluster. It is saying you can repeat that process multiple times. Multiple times the data items may move, may be included, maybe excluded from the cluster. But when should stop it? We should stop it until the changes no longer improve the cluster fit. What is the meaning of cluster fit? We should continue this movement. We should allow this movement to continue. Somebody is requesting to resend the attendance link. Okay, the same link we are using. So the question is that we should continue that process as long as it improve the cluster fit. Cluster fit means what? Means homogeneity and heterogeneity. What is the meaning of that? Means every time, suppose this is iteration 1, this is iteration 1, some assignment or some assignment process or some updation process over. Okay, iteration 1, and we have calculated the homogeneity and heterogeneity. Okay. Iteration 2, something happened again, assignment and updation, again it happened. We have to again calculate the homogeneity and heterogeneity. If it is improving, whatever the homogeneity and heterogeneity were there, if I'm going to improve it, means what I'm cluster fit, the cluster fit criteria, I'm going to create a more better cluster, you can say. Again we have to iterate it, again we have to iterate it, again we have to iterate it. We have to stop it when the homogeneity or a heterogeneity improvement is stopped, then we have to stop it. Okay, that is the thing they're talking about. That is over. At this point the process is stopped and the cluster are finalized. At this point, okay, so let me explain all this process through the flow chart. It helps us to memorize and understand the concept in very detail and very easy way. So start means, suppose we have a total number of cluster k. Randomly we have assigned the data point to the k number of cluster, and then we have to calculate the centroid of the each cluster. It is clear. Once we have a centroid of the each cluster, then we have to calculate the distance of the object to the cluster, means all the objects, not a member of that cluster. Whatever the whole data set you have to measure the distance from all the data points to all the clusters. And then a particular data point will be the part of the cluster to which centroid it is more closer. So the grouping based on the minimum distance means assignment and the adjustment. It is called updation or adjustment. So here the cluster boundary are going to be adjusted. Or again, we have to decide here, that is a decision we are making over here. We should go further in the new iteration or not. So means what we are going to do over here, we are going to see the homogeneity and heterogeneity or any other stopping criteria, if you may recall, if you may implement it. So if I'm my cluster fit criteria is continue improving, we should continue, go ahead. Otherwise, we should end it. That is the process. Now, I always love to discuss one more detail point: how to stop the clustering fit criteria. how to stop that iteration. So let's have a discussion about that. There are basically three stopping criteria. So what are the three stopping criteria? You may think about that. Changes means data points that are moving among or between the cluster does not improve the clustering fit criteria, whether homogeneity or whether the heterogeneity. The first sentence talking about, we observe that data points are continuously changing their clusters. They're moving here and there, but we are not getting advantage from them. Means it does not improve the cluster fit criteria. So what is the meaning of such movement? We should stop there. Okay, we don't worry about that. We should stop there. So this is one of the stopping criteria. Data point stop shifting. It may happen. Your algorithm converged. The next step, you you again calculate the distance from the centroid, and nothing happened in terms of movement. Every data points are a member of their cluster to which centroid it is very closer. So it means data points are not shifting. So what is the point of next iteration? There is no chance, because no movement, there is no chance to improve the cluster fit. We will stop it. Sometime it have seen in many applications the first and two condition doesn't occur. In some it may happen. So we are not allowing our implementation or algorithm to become an endless loop. It cannot be an endless process. So the solution is that third one. At the beginning, you can say that at most 100 iteration I may allow. So before 100 iteration, it is called a set in advance number of iteration. The maximum number of iteration you can set 100. So if before reaching to the 100 iteration, if condition either 1 or 2, your first or second occur, algorithm will converge and stop the execution. But first and second condition couldn't happen. After the 100 iteration, algorithm will automatically stop their execution. And whatever the condition is there, whatever the situation is there, whatever the assignment is there, we consider as a final. We consider as a final assignment, final literature. So in that way, we can think about the process that comes with the lesson. So here, now you can understand. You can try to recall what is going to happen with the clustering process. Typically, if you talk about the clustering process, if you talk about the k-means clustering, so k-means clustering is very simple. Only we need to think about uh, stopping criteria and assignment. Now, many of the candidate or participant may think how to measure the distance. We are talking about the items we have to observe the distance from centroid to everywhere. So what is the criteria? How to do it? What is the function? So let's have a discussion about that. I think many of you have from the different background, but you might have listened the word Euclidean distance. Euclidean distance is one of the method that most of the algorithm by default use to calculate the distance between two data points. So suppose a two-dimensional data space I'm talking about, we have a two data points x1, y1, x2, y2. It may be a one data point, it may be a centroid of the particular cluster, and the formula is given below. So in that way, you can measure the distance between two data points. And in a multidimensional way, it is very easy to extend the formula. There is no any rocket science over there. Similarly, the below is the example is given as a mathematical example where the data points are 2 or -1, -2, 2. How to use the Euclidean distance you can write over there. But it's correct. There is not only one Euclidean distance formula here that you should use it. A lot of options are there. Some of are listed over here. Like Manhattan distance you can use, Minkowski distance you can use, and Spearman correlation you can use, or edit the distance formula. It also very open and the point of research you want to apply, you can describe, you can implement your formula for a distance matrix. So which distance formula will work for you, you can understand it over here. So one thing, let me explain again. Suppose this is the data set is given to you, and you have used distance matrix M1, a distance formula N1. Somebody have used the same data but having another distance formula. Somebody have used another distance formula. You can consider this is the Euclidean distance, or this is a Manhattan distance. There is a correlation coefficient that you have used. So it is not a simple mathematics where 2 plus 2 always be 4. Whether you are using your laptop calculator, whether you are using a mobile calculator, whether you are using manually, it always be 4 by 4. It is not like that. What is the meaning of that? Once you change the underlying distance matrix, the different cluster you will get. The different cluster means suppose it has created k is equal to 2 for everything. K is equal to 2. Here also k is equal to 2. Here also k is equal to 2. Algorithm is also same k mean. Here algorithm is also same k mean suppose, and suppose k mean, same data set you have given, answer will be different. Whatever the two cluster here you are going to have, whatever the two cluster here you're going to have, whatever the two cluster here are going to have, okay, there are higher chance. I'm not saying always, 99.99%. This cluster is going to be different from this cluster. Means these two clusters are different from all the cluster, from all the cluster. Same answer, very less chance you will get the same answer. So that's why when you apply for a research, for any PhD work, you have to check all the possible distance matrix, and you will choose which one which give you the better result, better result means what? Cluster fit criteria you have to use. Cluster fit criteria means again homogeneity and heterogeneity I'm talking about. Okay, till this point everybody understood it. Everybody understood it. Then I will just will discuss one more point, then I will end the session. Okay, now we have a time, so that's why we are going to discuss the elbow method. So suppose what is the value of k? I think the background you know about. So what is the elbow method? Let me discuss over here. It will take 5 minutes. It's very interesting. I will show the implementation. Suppose x-axis is the k and y-axis is the any clustering criteria. Suppose homogeneity you're talking about, or heterogeneity, whatever you can consider. So k is equal to 2, k is equal to 3, k is equal to 4, k is equal to 5, k is equal to एक n number तक. So now you just run your algorithm for k is equal to 2. It will create some cluster. Suppose whatever the two cluster they have created, it is combined homogeneity is something. Suppose this is here. Okay, then k is equal to 3. 3 cluster they were created, and there is some combined homogeneity. Suppose this. So suppose it is happening over here like that. You have to need a graph. You have to need a graph like that. So such kind of graph will be in front of you always. Okay, here let me explain the meaning of graph. So it is a phenomena, it is a rule you can consider. The moment you increase the k, or you increase the value of k, homogeneity always increase. Or heterogeneity always increase. There is no way to decrease it. So that things are also you can validate from here. So k is equal to 2 something, the homogeneity was this one, suppose malo 2. K is equal to 3, homogeneity increase, k is equal to 5. Then again k is equal to something, k is equal to 7, then k is equal to 8, like that. But phenomena is also one thing you have to observe over here. The magnitude in the performance hike. The homogeneity increasing means performance hike I'm talking about. Initially, when you increase the value of k, that increment in performance or in the homogeneity is magnitude is bigger. Slowly the magnitude is going to be reduced, going to be reduced, going to be reduced, going to be reduced. Every time it will increase. Every time it will not going to fall. It is never going to fall. It will always increase. But the situation will come here sometime where the increment in the homogeneity or increment in the clustering fit criteria or increment in the performance will uh, 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 will become smaller. Then after some time it feels that the graph become flat. The graph becomes flat. So that point you have to find it out. That is called elbow. So this is one part of your hand. This is joint and another part of the hand. So against which point, against which k value that elbow method occur. So suppose k is equal to 5. So ideal value is 5, you can say. So again you have to run your k-means algorithm with the k is equal to 5. Whatever the answer you will get, that will be the perfect answer, the perfect cluster. So everybody got it? Everybody got it? The elbow method, what is that? Okay. Any question? Any question? Any doubt regarding this clustering or k-means clustering or any method we have studied right now? Any will pass through the origin? Origin means what? I'm not getting. One question is just I got it. Which will it pass through the origin? Which origin we are talking about? I didn't get. 0. How to measure homogeneity? Okay. How to measure the homogeneity? Or in the next class, next session, we are going to have it from the 3 o'clock. How to apply the clustering in stream data. So anywhere you can apply the clustering. Stream data having a number of column, number of features. Against that feature, you have to calculate the distance. No, but you have to update multiple time. You have to update multiple time. Then you have to apply the concept drift concept. So applying the streaming data multiple time clustering, you have to apply like that. You have to average it like that. The concept of concept drift you have to understand. So yeah, computation is required always. Text data always clustering always used in the text data. You need to coordinate for text data always. Text clustering, you have to understand the numerical way. Just I make it example here, the numerical data. In the text data, you text clustering is the only applications that is widely used in the text data. So that a different kind of you have to understand. Different type of measures are there for the text clustering. So like the typical Euclidean typical formula, they will not work over here. So different kind of you have to apply the how to check the document similarity. So what happened in the text clustering? Suppose this is document 1, this is document 2, this is document 3 is a part of one cluster. So document matching. Yeah, cosine similarity somebody have written nicely. So different formula are there to check the similarity of the text or similarity of the document, you can say. So change only concept will always be similar. So what we are going to cover in the next session, a very small session I will take around 3 o'clock if you say, or 3:15 we may log in. Hardly 30-minute session I will take, hardly 30